Hi everyone. So today we are going to learn section 10.7, the last section in chapter 10, and we are going to go over some probability. Now, our learning intention is that we will begin to learn about the world of probability by looking at methods for counting possible outcomes, and we have our success criteria here. I can compute empirical probability. I can compute theoretical probability. I'm able to find probability that an event will not occur. I can confidently find the probability of one event or a second event occurring, and I can confidently find the probability of one event and a second event occurring. So a lot of this, especially for you juniors, is going to show up on your SATs when you take them. This is a large section that I think it kind of like takes a step back from where we were with calculus and all that kind of stuff. Kind of comes into that more common sense math that I think you guys will get a lot more. So probability. Probabilities of events are expressed as numbers ranging from 0 to 1 or 0% to 100%. Okay, you can't have a negative probability. There's no negative chance that something can happen. You also can't have 110% chance of something happening. It's either between 0 and 100. The closer the probability is to 1, the more likely it is to happen. If the probability of any event, let's just say A, is 1, then that means it is guaranteed. Now, the closer the probability is to 0, the less likely that it is to happen. Now, if an event, the probability of it is 0, make that a little better, then it is impossible. That means this will never happen. Okay? So something like something that's guaranteed, it would be the probability that Miss Ralston is doing this video right now is guaranteed. Yes, I'm the only one doing this. A probability of 0 would be something like Barney is real. No, that's not true. It's impossible. So there we go. Now computing empirical probability. Now basically what this probability is, it's like your most basic one, and you're basically going to see the number of outcomes that fit this event. So if you're trying to find the probability of something happening, someone being a senior on campus, you're going to figure out, well, how many seniors are there on campus? Okay, so probability of being a senior, let's say that's this. You could have done S for senior, or you could just write out the word senior. You're going to put the number of seniors up top all over the total number of students. Okay. Now down bottom, it's the total number of occurred observances. We usually refer to this as N, or our sample size. What is the total number of people included in this all the time? So I'm going to show you something. You've probably seen these tables before. Definitely in Algebra 2, I believe they did that two-way tables last year. So this is a two-way or a contingency table. You can hear either one. Those of you that you will see these on the SAT, and those of you that plan on taking the statistics class next year instead of AP Calc, they call them contingency tables in the text, but you could also see them called two-way tables. So let's just get into this first example. When women turn 40, their gynecologists typically remind them that it is time to undergo a mammograph screening for breast cancer. The data in the table are based on 100,000 U.S. women ages 40 to 50 who participated in the mammograph screening. So the reason it's called a two-way table is because we are comparing these people based on two different variables. So this would be the mammogram result. So we ask people, oh, what was the result of your mammogram? Was it positive or negative? Now, then the second thing that we saw was whether they had breast cancer or not. Okay? Now, when you have two-way tables, all right, or contingency tables, I want to make sure you need the totals before finding probability. Okay, now notice how probability, okay. So this table, they're missing their row totals and their column totals. So I would just put it on the side like this when this happens. Alright, so how many people in all had breast cancer, whether positive or negative? Well, that adds up to 800. How many did not have breast cancer? When I add all this up, what do I get? I'm going to get 99,200. For positive, I got 7,664. And for negative, I got 92,000. Oh, come on, pen. 336. Now, there's usually one in the corner here, and this is where the sample size falls, the complete total. Now, how many people did we study in all? We studied 100,000, right? So, 100,000 would go here. And if you notice, if I added these two, my two rows together, they do add up to 100,000. And same for these two columns. So it's a nice way of kind of checking to make sure. Alright, so now that I have some information, I have my totals, I can now look into what I'm being asked. So, use the table to find for A, the probability that a woman, we only studied women, right, has breast cancer. So for A, I'm going to do probability of, I'll just BC, breast cancer. You could have also done A equals breast cancer. I'm fine with that if you just use one letter or something like that. So what I'm going to see is how many people in all had breast cancer from the study. So that would be the total of this column, 800. Now, I want to know out of all the women, right? How many women were there? There were 100,000. Now, I like to leave it this way so it shows the exactness of there were 800 out of 100,000 people if you're reading this. That the chances that you pick someone at random and they'd have breast cancer from this group. But you could simplify this to 0.008, which is about 0.8%. You could write it as a decimal or a percent, or you could write it as a fraction, simplified or not. I believe this would become 8 over 1,000, which is 2 over 2, 1 out of 125, I think. So that is your probability. Now for B, among the women without breast cancer. So now we're just looking at the women that don't have breast cancer, right? So no breast cancer is here. So we're just looking at these women. Find the probability of a positive mammogram. So we're trying to see those that don't have breast cancer, what's their chances of having a positive one? If it's positive, that makes you worry that you might have breast cancer, but we could still have a positive one and then all of a sudden we end up not having breast cancer. So, what I would call this type of probability, this is a conditional probability. Okay? Now the reason it's called a conditional probability is because we are considering, we're not looking at the whole group of people, right? We're looking specifically at women without breast cancer from the study. So there's a condition there, all right? So if you want to write conditional probabilities here, the way that you would see this written is something like probability of A and then line B. Now this line is called a given line. And the way you would see this is the probability would be how many are both A and B over the probability of the condition. Okay? So basically with conditional probability, it's like there's a but in it, right? Conditions are but. Like, oh, Mom, I want to go to this party. Your mom gives you this, oh, I'll let you go, but you got to clean your room first, right? That condition changes your chances of going to that party, right? So the condition is going to change the probability. It won't be the same as just the probability of A. Okay? Conditions have changed probability. So in this case, I'm looking of the women without breast cancer. So given no breast cancer, what's the probability that it was positive, right? I'm going to move that over. So how many women did not have breast cancer? I boxed it in, right? Sometimes visually, just to box in the section, the condition that you're looking at, it's helpful. So out of the 99,200 women that did not have breast cancer, how many tested positive? 6,944. Okay? Now, if you actually divide this, you want to change it into a decimal, you actually get an exact answer, 0.07, which means that about 7% of women that do not have breast cancer test positive for in the mammogram. Now, let's see, C. It says among the women with positive mammograms. So now we're looking just at positive, right? Oh, the positive, right? I gotta include the total as well. So now my condition flips. Find the probability of not having breast cancer. So, no breast cancer, given that we're only looking at people that are positive. So, out of those positive people, 7,664. How many did not have breast cancer? 6,944. Now, if I actually did the math on this, you would have to round, okay, about 0.906, which is about 90.6%. Okay? Please read MyMathLab because I want you to know in that blue, they may say leave it as an exact answer, simplify the fraction, round the decimal so many ways. What's the percentage? Okay, so you could get probability in so many different ways, so make sure you read that little bit within MyMathLab. Okay.